There's a monster the human fight against long before the dawn of human civilization. Plasmodium, a parasite that brings malaria to humans, had taken countless lives for thousands of years, and today we are going to discover how humans fought Plasmodium and how it evolves in this battle. Plasmodium was first found by Charles Louis Alphonse Laveran. This monster came from the African jungle, was first spread between non-human primates and mosquitoes at the beginning of human civilization. Reclamation brought this tiny monster to human, which started an unstoppable massacre to the human society. This disease troubles humans for more than 10,000 years, and we only found ways to control it in the last decades. There are more than 100 species of Plasmodium parasites, but only 4 of them are deadly to humans. Among these 4, the one biggest boss is called Plasmodium falciparum. It has been resistant to almost every medicine that humans develop to kill them, and it causes the highest chance to die if humans being infected. According to the World Health Organization, 2.19 billion people in 87 countries was infected with Plasmodium, and 435,000 of them were killed. Half of the world population mainly live in equatorial areas such as Southeast Asia and Africa are under the threat of infection. On average, one was killed by malaria in every minute. In the past 100 years, scientists are searching for a way to end this war, but history told us that this fight will not win easily. Killing Anopheles, the carrier of Plasmodium, was one huge step we achieved from the 1980s. Using mosquito net and insecticide, we successfully reduced 90% of the chance to be bitten by Anopheles. Developing medicine to cure parasite infection was another way to stop being killed by malaria. The first medicine the scientists discovered to cure malaria was the extraction from cinchona tree. Scientists used the extraction and made quinine, which was the most common medicine that people treated malaria in the early 18th century. It has the ability to combine with the DNA of Plasmodium, suppress the duplication process of DNA and transcription of RNA of Plasmodium while they were making protein during production. But the evolution of Plasmodium made them resistant to quinine, chloroquine, and primacrine medicine in the mid-20th centuries, when there were numbers of records of malaria bursts in Southeast Asia and Africa. In the 1970s, a Chinese scientist, Tu Youyou, and her team found artemisinin. It is an extraction from Artemisia annua, which had a record of curing malaria since 340 BC. The chemical structure of artemisinin can break the membrane of food vacuole and other organs of Plasmodium falciparum, deprive its nutrition, and results in its death. Currently, artemisinin is capable to suppress and kill 100% Plasmodium falciparum. However, there are reports suggesting not to use artemisinin alone when treating Plasmodium falciparum, since it will develop its resistance to artemisinin. If artemisinin fails to kill Plasmodium falciparum, we will be in trouble at this war. Plasmodium is famous for its ability in mutation. It always makes mistakes when copying its DNA to its children. Also, it can breed both sexually and asexually, depends on the environment they are in. Because of that, scientists failed to develop an effective vaccine for Plasmodium, and even the medicine that kills it will lose effect over time. Recently, there were reports from World Health Organizations that Plasmodium falciparum in Southeast Asia has certain level of resistance to artemisinin, which gained from the genetic mutation. In the evolutionary history, one dominant biotic factor is actually that humans gave Plasmodium parasites an artificially selection, which makes them evolve to be strong enough in against of the current medicine. Today, scientists use artemisinin combined treatment, namely ACT, to cure malaria. Combining artemisinin and other medicine make it more complex for Plasmodium to develop antibodies to the medicine. It dramatically extended the protection of the medicine and made it activated much faster than use artemisinin alone. Scientists also surveillance the resistance of Plasmodium to assistive medicine. If one assistive medicine becomes ineffective to Plasmodium, an alternative will be for replacement in time to maintain the effect of the medicine. Since artemisinin decomposes in hours in human body, a 5 to 7 days treatment is introduced to replace the original 3 days treatment, which eliminates Plasmodium before the artemisinin-resistant children are reproduced and spread out again. However, the evolution history of Plasmodium told us that this eukaryote devil will not stop killing people. Since fighting against Plasmodium with artemisinin is a kind of artificial selection, unless every single Plasmodium is eliminated before they evolved, the evolved survivors will have a chance to grow in population and take their revenge back to human. If one day the artemisinin cannot protect us anymore, what will be the next lifesaver?